What's up, .NET developers? Do you just have a chunk of code and maybe it reacts on a particular event and you just want it to run? Well, maybe we should take a look at some of the serverless options that we have in AWS. And we're going to take a look today at AWS Lambda and API Gateway right here on AWS for the .NET developer. Hey folks, Isaac Lemon here with another edition of AWS for the .NET Developer. If you're enjoying the content here, be sure to like, subscribe, as well as comment on the video and let me know what other .NET AWS content you want to see. So if you've been following along in this series, we started at full control over the hosts that our apps run on AWS, that being Amazon VC2, which is the virtual machine offering in AWS. We then talked about all the different ways we can build containerized .NET applications in AWS, Amazon Elastic Container Service, Elastic Kubernetes Service, so on and so forth. And if you haven't seen those videos, be sure to take a look at the .NET AWS playlist on this channel. All right, but if you're writing code that just needs to run based on a specific event, for instance, at a scheduled time, when a database record gets updated, or even an HTTP request, AWS Lambda is a great option. Lambda is a serverless compute engine that allows you to run your code without provisioning, managing, or frankly caring about the underlying infrastructure to run your app. This is a great option if you're building apps that follow some event-driven architecture, as well as apps that don't have some state that you need to worry about or manage. And when we are building web applications that are APIs, we need to be able to effectively route traffic. Amazon API Gateway is a fully managed service that enables developers to create, publish, maintain, monitor, and secure those APIs at any scale. It is more than likely that you have heard at least the name AWS Lambda, and you may even have a rough idea of what the service is. If not, AWS Lambda is a service that allows you to run a function or smaller piece of functionality on demand without the need to manage the underlying infrastructure at all. The phrase commonly used in the industry is serverless, as the thought is we think about our code more and the server less. So regardless of your thoughts on the phrase, the ability to just focus on the functionality that you are trying to light up is quite valuable. No other scenario is more interesting than when we want to build an event-driven solution. So when I say event-driven, I think about how the apps we build often need to act on some event. Maybe a database record gets updated, a file gets dropped into a storage bucket, or even at a particular time of the day. This scenario is the perfect time to use AWS Lambda, as you can configure these triggers right in the AWS console and seamlessly see executions of your code when those use cases are hit. Another great example of when to use AWS Lambda are when scale is the most important. Imagine being a retail company with an e-commerce store on Black Friday in the United States, and your bottom line is immediately dependent on how your website reacts to demands of customers. AWS Lambda scale automatically based on load, so you can rest assured that your app will be scalable and robust when you need it the most. But the number one benefit to most when it comes to serverless technologies like AWS Lambda is the pricing model. Since you only pay for when your AWS Lambda functions are run, you get an exceptional value as you truly pay for when your app is actively doing things. We have conversations with customers all the time saying they are initially shocked at how low their AWS Lambda consumption bill is when they first started using the technology. And as I mentioned earlier, you have easy access to metrics and execution telemetry data right from the AWS console for your running AWS Lambda functions. This is incredibly helpful to get an idea of how your apps are behaving in the wild. One often used example for AWS Lambda are APIs available over REST. When we have APIs, we want to ensure they are secure and accessible no matter where customers are. And when we're building APIs, look no further than leveraging Amazon API Gateway. Amazon API Gateway is a fully managed service that makes it easy for developers to publish, maintain, monitor, secure, and operate APIs at any scale. It is a pay-as-you-go service that takes care of all the undifferentiated heavy lifting involved in securing and reliably running APIs at scale. So with mobile applications and IoT devices becoming more and more prevalent as platforms to build applications on, the need to have a backend service that provides a set of APIs to those clients is very, very important. To authorize and verify API requests to AWS services, API Gateway allows you to leverage AWS identity and IAM and other access policies to properly secure your APIs and any underlying services they consume. So one great example is using AWS Lambda functions to verify and authorize bearer tokens like JWT or SAML assertions. Now let's take a look at some of the tools to help us build .NET applications on Lambda, as well as some different ways that we can build those apps and deploy them to AWS. Before we get started actually building out some of our projects, let's take a look at some of the necessary tools that we're going to need to get Lambda up and running. So the first place that I recommend people looking is the AWS Lambda .NET repository in the AWS organization on GitHub. So inside of here, you can see all of our open source tooling for Lambda for .NET. So specifically, there are two things that I think are really important to call out. So the first one being the Amazon Lambda Tools .NET Global Tool. So if you're not familiar with .NET Global Tools, they are mechanisms that allow you to install particular pieces of functionality that you can then access via the command line. So for instance, when you run .NET tool install -d for global at amazon.lambda.tools, you get all the Amazon Lambda tools, and we'll talk about what those are in a second. And then the second thing that's really, really important to call out are the CLI templates. So the AWS Lambda team and the .NET team at AWS has put together a handful of really valuable templates to get started as you build .NET application with AWS Lambda. And the way that you do install those templates is .NET new -I, which means you're going to install, and then amazon.lambda.templates. And in this particular format, this will give you a handful of different Lambda templates for default projects. So you have some ones for an empty function, or Lambda simple SQS function, or S3 function, and so on and so forth. So what those do is they give you the ability to get started really quickly building applications for AWS Lambda. Now let's hop into the command line and actually go through installing some of these tools. So I already have them installed on my machine, but we can actually just go through the process. So I'm just going to go this update command just to make sure I have the latest version. So in here, so .NET tool update -g -amazon lambda.tools, and what this will do is this will install the latest version. So it was reinstalled, and the latest version as this recording is 5.6.2. And the next thing that I want to be able to do is I want to install those templates. So I'll scroll down here, and I will get .NET new. I'll take this command here, and I'll open up my command line window again. And then after installing this, I should have all of the specific templates. So as you can see here, there's a handful of templates that already exist, which is really, really awesome. And what I want to do is I want to go through just a couple of different ways that we can create AWS Lambda projects in .NET, and a couple of different ways we can deploy them. So I'm going to open up Visual Studio, because that's the place that whenever I think about building .NET apps, I love to go into Visual Studio. And I'm in the new file, the new project dialog. So as you can see here, I can open up an AWS Lambda project, which is my recent ones here. And I can specify a particular folder, and then let's just call this .NET Lambda. And it says this directory is not empty. It's probably because I have another one previously. So let's just go here. All right, so we have that. I'm going to create, and then it's going to open up a dialog for the particular project type that I want to mention earlier. This goes from those templates that I talked about. So let's just go with an empty function in this particular case. But I also have options for native AOT using .NET 7, as well as custom runtimes and some other ones like Alexa support and things like that. So we'll take a look at some of those later on in this video. But let's just go finish. And what this is going to do is it's going to bootstrap a template project for AWS Lambda functions. After that's complete, we can just go ahead and take a look at what's here. So let's close out this What's New folder, or new tab. Let's just pin this Solution Explorer over and move this over. So we can see there's a handful of different files that were created as part of our templates. A README file, which kind of walks us through some of the high-level concepts of what we're doing here. So it shows you how to deploy the function and all the different mechanisms. We've already done these sort of things already, but we'll walk through them in more detail. Then the next thing that's really important is let's take a look at the CS project. So in this particular case, it's a .NET 6 application. It's using implicit usings, and it's using a custom property called AWS project type. And what that does is that bootstraps a couple of really, really interesting pieces of functionality. So for instance, one of those things being a testing harness for Lambda functions, which I'll show in a second. So this is what comes right out of the box when you create a new Lambda project. And how AWS Lambdas are actually, how they actually run, let me just minimize this here, is we have this idea of a function handler. And what a function handler basically is, it is the entry point for our functions. So we have a chunk of code to run. In this particular case, I have a function handler that takes in a string input and the Lambda context. And what it does is it just returns that same string, but then in all uppercase. So for instance, if I was to provide hello, it would return in all caps, hello. We can actually see what that looks like here. If we actually go up, instead of the typical like run or debug or some of the other things, we have this Mock Lambda Test Tool. What this is going to do is it's going to create a testing harness for AWS Lambda functions. And what that does is it pops open another window. So let me move over that window here. And as you can see, this is a UI that allows us to create requests against the local version or the local running AWS Lambda function that we have. So you can specify a default credential that you might have for AWS, or you can specify a region, or you can just do some test output. And we have some sample requests, like if you have for things like Alexa or different AWS services, and it's really great stuff there. But what if I type in hello, because remember what our function does is it takes a string and then it returns it all in uppercase. So as you can see here, we have this right here. So really, that's a really simple demo of what some of the great experiences you are, and they're be able to test different Lambda functions that you have. And like I said, there are a handful of example requests. So if you created some mechanisms, for instance, for S3 putting and deleting, like every single time you put something into an S3 bucket or you delete something from an S3 bucket, you have the ability to trigger a function. That really great experience to be able to have like a default request. And you can take a look at what that looks like in something like this. So if we close this out, and the next cool thing that's really cool, since we have the AWS toolkit in Visual Studio already pre-installed, we can actually deploy this right to AWS. So I can right-click here, and if I right-click there, I have this Publish to AWS Lambda option on my project. So I can click on that, and then from there I can actually specify some criteria here. So I can specify a function name, or if I have one already existing, so let's just go .NET Lambda, for instance, and I can specify the configuration as well as the framework and the architecture, and also region. So if I click next, the next thing it wants us to do is we can add some more advanced configuration. So I can specify the amount of memory that the function is taking up, or the VPC that it's connected to, or any additional IAM rules that I want to map to. So if I click upload here, what this is going to do is it's going to build up my project, it's going to publish it, or it's going to zip it, and it's going to publish that project, that zip file that gets packaged up to AWS Lambda to be able to run. And once that's done, it's going to actually pop open a window which allows me to test against these particular things. So right now it's in the process of being created, and now it's successful. So I can actually then specify, let's just do this again. So let's just do hello, and I could simple request, and then we go all caps and hello. That's pretty awesome. So really quickly, we were able to create a AWS Lambda function. We were able to test it locally and then deploy it using Visual Studio. So that's really great. Like I mentioned, there are other ways to create .NET 6 or .NET 7 Lambda projects and deploy out without having to use Visual Studio. And one of them is via the command line. So let's actually open up our command line, and let's actually walk through the process of creating a new project and deploying it out using the command line. So the first thing I want to do is I just want to .NET new, and I want to use Lambda, and then the dot to specify what template I want to use. I want to use the native AOT project. So the latest versions of .NET 7 have some great work that's been done in the ahead of time compile space that really allows us to get some really great performance out of our .NET 7 applications. So native AOT, and I'm going to specify the folder name. Let's just call this Lambda native AOT, right? And then this is going to create a new folder. So we can actually go into there, and let's just open this up in VS Code. VS Code Insiders. All right, and I'll move this over to this window here. So the first thing that you'll notice is that there's two folders. There's a source folder and a test folder. So inside of the test folder, let's just close out this, close out that. So there in the test folder, there is some test harnesses to test this particular our function handler. So the format is still the same. We still have a function handler in .NET 7 as well as we did in .NET 6. But if we go into our source code here, we have a handful of things. So we have now there's a bit more code in our function CS. Let's first take a look at our CS project. You notice that it's .NET 7, and you know that we have an assembly name of Bootstrap. Because if you look at the Microsoft documentation for AOT, there's some additional steps that you need to configure as it pertains to setting up ahead of time compiling for your applications. And the template for AWS Lambda has those already pre-baked in. So we have the rd.xml, which specifies Bootstrap required all. All this is documented on the Microsoft side, and I'll put a link to that in the notes for this video. But the most important thing to call out with this particular, let's just zoom in too, is that there is a bit more code in our function.cs class now. So the first thing that you'll probably notice is that now there's a static task main, which it looks very, very similar to like how you would have a console application, right? And then also, you'll notice that this is even kind of similar to when we build things in ASP.NET Core, right? We have these fluent sort of extensions for build, run, async. What this does is it basically sets up the Bootstrap builder to be able to specify that entry point. Because one of the things that we lose with AOT is that anything that requires reflection doesn't work anymore because of just the way that AOT works. So things like JSON serialization, so if you're using system.text.json or Newtonsoft JSON.net, you are going to have to use source generators. So there's a ton of documentation around source generators, so I heavily recommend you take a look at some of that. But from our perspective, what we want to do is we specify a JSON serializable class, and what this partial class basically does is it derives from system.text.json, so it allows us to generate that reflection that we need to be able to parse JSON data that comes across. So we have that, and we tag that appropriately. And then if we look at our source generator Lambda JSON serializer, you notice that it's the same thing. So the next thing is we take a look at our function handler, and the code for that is still the same, right? So we still have the string.input, and then we upper that as so. So how do I take this project that I just created, and how do I deploy it up to AWS? So how I can do that is I can also use, I can use the .NET Lambda tools that I mentioned earlier to deploy this up. So if I go back into my command line here, and let's just actually go into the source folder for that project. So as you can see here, and I'm using my posh here, which shows me it's .NET 7 is the latest version that's running here. Let's move this out of the way, and then if I go .NET Lambda deploy function, this is going to walk me through actually using Docker, so using a containerized version of our application, Dockerizing it up, and then sending it up to Lambda to run our .NET 7 applications with AOT compiled Lambda functions running in AWS Lambda. So once this is done, I can then actually invoke it. And let's skip ahead to when the function is actually deployed, and we can actually take a look at that. So what it'll actually do in the process of creating our new function is it wants us to create a function name. So let's just give it a function name. So let's go AWS AOT Lambda. So basically what this does is that we've already pulled down an Amazon Linux 2 based Docker image, and we've compiled our code inside that. And then the next thing it's going to do is it's going to publish up our code. It's going to zip it. It already published up our code. It's zipping up. Now we have a publish archive, which is in this directory, this bin release native AOT.zip. So what we're going to do is we're going to create a function with this name, and we're going to publish or zip up and send our zip file that we have up to AWS Lambda. The first thing that it's going to want to do before we do that is to specify an IAM role. So we'll just give it, we'll just say 13. So create a new IAM role. And let's just call this test AOT Lambda. And then it's going to give us, okay, what are all the list of all of the roles we want. So let's just have it be full access in this particular case. So 13. So then it's going to propagate that out, and then we're done. So now we have an AWS Lambda function that's actually running in AWS. And now that our function is deployed, we can actually test it using the CLI as well. So we can just do .NET Lambda and that was AWS AOT Lambda. That was the name of it. We want to invoke the function, so we specify invoke function, and then all we have to do is specify the payload. So that basically just stipulates what we're sending across. So we're going to send across hello. And as you can see here, we have a response payload of capitalized hello. So that's another really cool way. So using the command line only to create and deploy out AWS Lambda function. In this case, a .NET 7 native AOT Lambda function to AWS. And finally, there's one other way too to be able to deploy our .NET AWS Lambda functions to AWS, and that is using SAM, or the Serverless Application Model that's provided by AWS. And how we can actually do that is actually, let's just hop out of here and go to the root of this folder. So now we're in just the root dev folder, and I'm going to type in SAM in it. So the Serverless Application Model, or SAM, has its own CLI that allows us to create new projects and deploy them out to AWS Lambda. So it specifies what template do you want. So we're just going to go with Quick Start Template 1, and then let's just do Hello World. And then it says use the most popular runtime. In this particular case, at the time, it's Python and Zip, but we can say no in this case. And then it gives us a bunch of different options. And the option number one is AOT.net, which is provided by Amazon Linux 2. So specify that. And then it's going to want, if we want to set up X-ray tracing, which is APM or monitoring, we're going to say no in this particular case. And then let's just give it a name. So let's just call it SAM.net. And then what it's going to do is it's going to clone a repository that we have that's at AWS SAM CLI app templates. It might take a bit. It's going to clone this, and we're going to have a project that is all ready to deploy out to AWS. And now that that's complete, we can actually take a look at that. So let's actually let's cd into here. So let's cd into sam.net. Let's just take a look at the structure of the project. So we can do, again, code, insiders, open this up in VS Code, open this up. And as you can see here, there's a test project, there is a source project, and there's an events project. So what's a bit different about serverless application models, the expectation is that everything that's needed for your serverless applications is available to you right from the templates that are created. But the biggest thing to call out is that if you look at the code is basically the same between all of these. This template is a little bit different because it's not a two upper. What this particular code does is it checks the IP address of the machine that the Lambda function is running on, and it outputs that out. So that's kind of cool. So we can actually take this a couple of steps further. So the next thing that we can do is we can build this application. So let's do that. Let's hop over here, and we can go that. Let's go SAM build. And what this is going to do is this is going to build all of the pieces of our serverless project. And what's cool about SAM is that, like I mentioned, everything is included. So if you want to, you can configure monitoring, like we saw a bit earlier. You can use other runtimes other than .NET. I know .NET is the most important for us, but you can use Python or JavaScript or other things as well. So once this is actually configured and built, we can then deploy it in a guided fashion, and we'll fast forward to when we can do that in a second. And now that our SAM application is built, we can actually deploy it. So the next thing we can do is go SAM, deploy, and then guided. And what this will do is it'll walk us through actually deploying this application. So we're going to specify a stack name, because what this uses is CloudFormation, which is an AWS service to define infrastructure for applications. So we're going to give it a stack name, and then a region, so East US 1, US East 1, and then confirm resources for deploy. Let's just go no to skip ahead, allow that. We're going to allow a new IAM role to be created, not disable rollback, and that's okay. So the next thing this is going to do, it's not 100% sure what I did wrong here, but let's just try that again. So SAM deploy guided, I'm going to give it a name, name that, and then confirm resources. So let's just click yes. Let's allow SAM role creation, and sure, let's apply rollback, and that's okay. And we're going to save this arguments to a configuration file, and that's the toml for that. We're going to have a default configuration environment, and then it's going to start walking through the process of uploading our application, our SAM application, to CloudFormation to start to build that out. And this does take a second because it's building all the infrastructure for us, but when we come back, we should be able to test it. All right, and now that we've had validated our deployment, so these are all the things that are going to get deployed out, we can actually deploy this change set out. So let's click Y here, and then, like I mentioned, CloudFormation is going to walk through the process of deploying out all of these different, or creating all these different infrastructure components for our serverless application. All right, and now that our SAM app is created, we have our stack has been created, and let's actually hop over to the AWS console and take a look at our Lambda function part of it. And as you can see here, we have a new function called SAM app hello world function. So we can open that up, and this will take us and we can look at all of the function overview. So as you can see, we have a serverless function here, and then we have an API gateway in front of it. And we can go and take a look at some, we can test this stuff. We can test our events, we can monitor them, we can configure, but let's just actually take a look at this application. So this function belongs to an application, so click here to manage this. Let's click that. And then we can set up a development environment for here if we want. We can specify API endpoints, we can do different monitoring, we can look at our deployment history, so look at our SAM template, which is specified there, which again, all this stuff, we'll go into details in a different video, but just want to show you all the different pieces that we have for SAM. We can go and look at our serverless REST API here, open that up, and we could get into the test harness for API gateway. So I can specify here, look at the get for the hello, and then I can click test. And then it gives me the options. I can specify any query strings or headers that I want, click test. And then it's going to say hello world location. And this is from where the request came from. So that's really, really cool. And I think one thing that we could also do is let's just go back to Lambda and actually walk through the process of setting up an API gateway. So let's just take that same SAM app that we created earlier, that hello world function. So as you can see, there's already one API gateway, but what if I wanted to configure another API gateway? Maybe I have two different API gateways that route to the same AWS Lambda. And I can do that inside of here in the AWS Lambda console right here, or I could do it from API gateway side. So let's just try that. So let's go to API gateway, search for that. And from there, we can create a new API. And in here, we can specify what our API type is. Let's just go to HTTP API for simplicity. And then from there, we can create an integration. So we'll add an integration. We'll have it be an existing API Lambda function, and then we specify our region and which function we want to point to. So in this particular case, let's just do this hello function again, and then we give it a name. We can just give this hello. Let's just give it an API name of hello. And then the next thing is we want to configure the route. So basically, what route we want to exist when somebody hits our particular API gateway and they hit the route, hello route, we want to route them to that hello world function. So let's do that, click next, save our stages as default, click next and create. And then what we're going to be able to do then is we can actually then test these particular functions. So let's just open up like VS Code, for instance. Let me just open up a new VS Code window. Give me a second while that loads. Hop over here. Okay, so I'm set at VS Code, and I can use something like Thunder Client, which is a REST client that exists inside of Visual Studio Code. And what I want to be able to do is I can just take the URL for this particular endpoint. So we have this endpoint here. This is our invoke URL, and we know, excuse me, that the API endpoint, is /hello. So if we make a request to this, if we click send, we get that same message. So hello world and the location from where this function ran. So that shows you really, really quickly how to actually test these Lambda functions that are behind API gateway through other tools outside the AWS console. So for instance, you could do this with Postman or Thunder Client or other different REST clients that you might have on your machine. And there you have it, folks. In just a short amount of time, 3 different ways to take our .NET 6, .NET 7 code and deploy it up to AWS and have it run really, really effectively in AWS Lambda. So that's really exciting. If you like this sort of content, be sure to like, subscribe, follow wherever you're seeing it. And let me know if you want to see other sort of content around .NET and AWS. I would love to hear what you're building as well. So my name is Isaac Levin, and we'll see you next time on AWS for the .NET Developer.